Now we're going to start talking about how we represent the chemical reactions that you saw taking place yesterday. How do we represent that on paper? We need to be able to write that down so that we can communicate with other scientists as far as what kind of things that we're seeing in the laboratory. So the first thing I need for you to do is to grab an index card and write down what we're going to call the 7 diatomic elements. We talked about in the last chapter, a couple chapters ago, how sometimes atoms will bond to each other to become more stable. And sometimes when they bond together, they will bond to atoms of other types, and sometimes they will bond to atoms of the same type. There are 7 elements in particular where the atoms will bond to each other to form a diatomic element, and di means 2. And then you have the word atom in the middle, so that means there are 2 atoms that are hooked together so that they are very, very stable. Those 7 diatomic elements are hydrogen, and then if you actually look on the periodic table, you'll see that these others are all right next to each other on the periodic table. They go across and then they go down, so they're all grouped together. So nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And these 4 guys right here are all halogens. They're right next to the noble gases on the periodic table. And then nitrogen and oxygen are next to fluorine in that same row. And then hydrogen's kind of off by itself. But all 7 of these tend to hook to each other to become more stable. And so you'll never see an atom of oxygen or an atom of iodine or an atom of nitrogen all by itself. It's always hooked to a buddy. So I want you to write those down, because as you're putting these into chemical equations, you need to be sure that you never have a single atom of one of these, that you always have them doubled up. So when I start writing a formula or writing an equation for a chemical reaction, I'm going to write it something like this. Let's take the example that hydrogen and oxygen react together to form water. So hydrogen is one of the 7 diatomic elements, and it's always going to be hooked to another hydrogen. So I have to write it as H2. I can't write it as just H. So hydrogen and oxygen, so I'm going to use a plus sign just like in a math equation, and oxygen is also diatomic, so I have to have 2 of them always hooked together. They react together to make water, and probably everybody knows the chemical formula for water is H2O. We see that a lot. Okay, so on this side of the equation, these are called the reactants. So both hydrogen and oxygen are called reactants. Water is called the product. And this arrow, if you're going to read this, sometimes it's read as yields, sometimes it's read to make or to form when you read this. And then if you see the plus sign, normally you're going to read that as reacts with. So to read this chemical equation, it's almost like a chemical sentence. I would say hydrogen reacts with oxygen to form water. Okay, reactants and products. Now, there's a couple of different kinds of numbers up here. Well, actually, there's only one right now. I'll put another one up here in a second. These numbers down here on the bottom are called subscripts. And as we've learned before when we were writing chemical formulas in the last chapter, we know that those tell us how many of an atom are in a particular compound. So this 2, and this 2 are all subscripts. Now, the law of conservation of matter, which again we talked about in chapter 2, tells us that matter can't be created or destroyed. Remember, only our creator can create or destroy matter. We're not capable of doing that. It can only change form. So the law of conservation of matter says you can't start out with more on one side than you have on the other side. So if I start out with 2 atoms of hydrogen over here, and I have 2 atoms of oxygen over here, I better have 2 atoms of hydrogen and 2 atoms of oxygen on the other side. Well, do I? Well, if I look, I can see that I have 2 atoms of hydrogen, but water only has 1 atom of oxygen. So what am I going to do about that? Because I've just disobeyed the law of conservation of matter, and that isn't allowed. So how am I going to go about fixing this? Well, what I'm going to do is I am going to have to do something so that I can have enough water on this side so that everything on both sides is going to be balanced as far as number of atoms. So what I can do is I can put a 2 in front of this to say I'm going to need 2 water molecules here. And so if I do that, that means I'm going to have 2 really of everything that's in here. Okay, so that means I'm going to have 2 oxygens. And so now that matches what I have over here, right? I have 2 oxygen atoms, and then I have 2 oxygen atoms here. But now I also have 2 H2s, and so that means I have a total of 4 hydrogens, and now I only have 2 over here. So in order to make that balance, I'm going to have to put a 2 in front of the hydrogen over here. These numbers that I'm adding in front of my formulas are called coefficients. And so the rule is when you go to balance a chemical equation, you can change the coefficients, but you cannot change the subscripts, because the subscripts have to do with, remember how we talked about how this one's going to transfer electrons over here, they're going to share electrons together, and so I can't change those subscripts, but I can change the coefficients. Let me try to show you also here what this would look like down on an atomic level. So if I have hydrogen, I would have something that looked sort of like this, if I just want to represent it with balls and sticks, so to speak. A hydrogen atom is going to have 2 hydrogens kind of hooked together. And so I'm going to have, according to this, I need 2 of them that look like that. If I use green for my oxygen is also hooked together. And so if I would represent it with balls like this, then here's an oxygen molecule. When I get to the other side, I have H2O. And so what that means is that I'm going to have 1 oxygen, and it's going to be hooked to 2 hydrogens like that. And so similarly, since I have 2 of them, I'm going to have to draw 2 water molecules. So it's going to look something like this. And so now, with the drawings that I have here, you can see that I have 1, 2, 3, 4 hydrogens on this side, and I have 1, 2, 3, 4 hydrogens on this side. If I have oxygen, I have 1, 2 on this side, and I have 1, 2 on this side. So I have the same number of hydrogens and the same number of oxygens on each side. So this is now called a balanced chemical equation, and I have obeyed the law of conservation of matter. Okay? So what I'm going to do is, I'm going to get rid of this, first of all. And I'm going to put some equations up here, and we're going to figure out if the equations are balanced or not. Now today, all I'm worried about is that you can tell if the equations are balanced. We're going to learn how to balance them in the upcoming lessons, but today we're just going to try to figure out if they're balanced or not. So let's look at this one first. HCl plus Ca yields. So we'll look at this one first. Okay. So let's look at this and see if we can figure out if this is balanced or not. So here I have a hydrogen. How many hydrogens do I have on this side? Well, if there's no subscript down here, remember that really means that there was a 1. So I have 1 hydrogen. How many chlorines do I have? Right, I just have 1. And then here I have a calcium. How many calciums do I have? Again, just 1. So now when I look at this side over here, what do I have? How many calciums do I have? I have 1. How many chlorines do I have? Well, there's a subscript of a 2 down there, so that means I've got 2. How many hydrogens do I have? Yep, I have 2 of those as well. So, is this balanced? It most certainly is not, because even though my calciums match up on each side, my chlorines and my hydrogens do not match up. So is this balanced? The answer is no, it is not balanced. Okay? We're not going to worry about balancing it today. We'll get to that tomorrow. Let's look at another one here. CaS plus O2. All right, how about this one? Is this one balanced? Well, I've got one calcium on this side. How many calciums on the other side? One. I have one sulfur on this side. How many on the other side? That's right, just one. How about oxygens? How many do I have on this side? Two. How about on this side? Yeah, just one. So is this one balanced? No, this one is not balanced either. Okay, let's look at one more. Let's say that I have, get that off of there. Let's say that I have NaCl plus KBr, and when they react, it's going to form KCl plus NaBr. Okay, let's see if we can figure out if this one's balanced or not. Okay, I have one Na, one sodium on this side. How many are on this side? Yep, just one. Chlorine, how many do I have here? One. On this side I have just one. Potassium, how many on this side? One, and on this side there is one. And bromine, I have one on this side, and I have one on this side. So is this equation balanced? Yes, this one is balanced. Okay? So for today, what I want you to do is to take the worksheet that I gave you for today, and you'll find that in a separate document in the additional email that I sent to you. And your job for today is just simply to determine if the equations are balanced or not. And then tomorrow, we're going to learn how to balance them.